In the previous video, we added and subtracted rational expressions with equal denominators. It was very nice and easy. Unfortunately, in this video, we're going to add and subtract rational expressions with not equal denominators. And look first at the very simple problem, 1/2 plus 1/3. And it was nice in the previous videos to have common equal denominators. So the goal here is to change those two fractions to have equal denominators. How we are going to do it? I prepared this thing right here for you, and you can see that this is the same expression, just I left some spaces on the left. Why? Because I know that in order to make those denominators equal, what I can legally do, I can multiply the top and bottom of the fraction with the same number. I cannot just do what I want. I cannot just change 2 to 3 or 3 to 2. But what I really can do, I can multiply top and bottom of the fraction with the same number, because basically speaking, you're going to multiply by 1. So I do know that if I'm going to multiply the bottom of this fraction by 3, now of course I have to do the same for the top one, and by multiplying this by 2, I will receive two equal denominators. This is 6 and this is 6. So I will have 3 over 6 for the first fraction. Second one is 2 over 6. Altogether, it's 5 over 6, and we are done. Now we're going to apply the same reasoning for more complicated examples. For example, this one. So I have addition of two fractions with clearly not equal denominators, but I'm going to apply the same reasoning as I did for the first one. So I'm going to move this fraction right here. It's the same expression. I just wanted to show the difference. Here I'm going to do some work here. Here was the original one. So I'm going to look at the denominator of the first fraction, this one right here, and see which one is missing from this one. What factors are missing from these denominators? And I can see that this denominator is missing 2. So I can multiply by 2 top and bottom of the fraction. But before I'm going to do anything at all to the denominator, and to the numerator as well, I have to put parentheses around quantities. If you remember the previous videos, we were talking about this. So I'm going to this is the quantity and this is the quantity I put around parentheses. Now, like I said, I'm going to multiply top and bottom of this fraction by missing factor, which is 2. So I'm going to multiply this one by 2 and this is by 2. Now, here is I have a squared and here is a. So here is 2 factors of a, here is just 1 factor of a. So I have more a's here than here. So we're going to leave it alone. Now let's look at this denominator. So I have 2 and 2, the same numbers. Now I have just 1 factor of a here and 2 factors of a here. So I'm missing 1 factor of a. I'm going to multiply top and bottom of this fraction by a. Now, do I have equal denominators? Yes, I do. 2a squared here, 2a squared here, and I will have two fractions with the same denominator, 2a squared. So I prepare my equal denominators, 2a squared. On the top, I will have to distribute 2a minus 1, so 2a minus 2, right? So I distributed this. So here is my quantity right here. Here is I'm going to distribute a over each term here, and I will have a squared plus a. Now, since the denominators are the same, I can put them on the same division bar. The same common denominator, 2a squared. And, okay, there is no negative in front, so I can get rid of parentheses. 2a minus 2. Next thing, also there is no negative, it's plus sign, it's good. So plus a squared, and then plus a. And the only thing what is left is to add and we will have a squared on the top, 2a plus a, we will have 3a, and minus 2 over 2a squared. So after we combine like terms, we can look, okay, can we factor more something? Or here is the biggest mistake what people can say, okay, but we can cross out a and a, or a squared and a squared here. But this is the big mistake, because we can cancel out only factors. We can do anything here, we cannot factor more, and therefore this one is the answer. So you probably noticed that you're professional enough and you learn probably about least common denominators. And what we did, we actually found least common denominators for fractions here. The only thing why I'm avoiding to do it, because I don't know for what reason, but when I say least common denominator or least common multiple, my students are getting kind of sad and bored. That's why keep it in your mind. Your goal is to create fractions with equal denominators. How you're going to do it? By multiplying top and bottom of the fraction with the same number. Now let me show you two more examples. Here is one of them. I'm going to just start doing this for you. The rest is going to be yours. So somebody can tell me, here is, okay, but this is not rational expressions. Oh, but they do. They are rational expressions because if you can see, this factor c has negative exponent. And in order to get rid of negative exponent, we have to move c down. So basically speaking, this is over 1, right? Over 1. And if you move this factor down, you are going to receive 2d on the top over c. On this fraction, we will have 2c is not guilty of having negative exponent. However, d is going to go down because it's negative. So d. Now you're going to use the same idea. You're going to change this fraction to have equal denominators and perform everything like we did in the previous example. Hopefully understood. And I'm going to, so you're going to pause this right now. You're going to do this example and I'm going to give you the answer. And here is the answer. So this is what you want to get.